Take a close look at this picture. I thought this picture was very moving, how they superimposed the actual pilots on the back of it. I thought this was really neat. It's one of the books that I actually bought when I was in England last time, and there's only one problem. We went to pack our suitcase again and found that we had never taken it out of the suitcase. And what it is, it's Spitfires in American markings. And I thought, well, shows you what I know, but this was a great little book. It has some really nice photos in it. And I always thought one of the things would be really cool is doing a Mustang in British trim and a Spitfire in American trim. That would be kind of a unique thing. Anyway, just a thought. Now, I didn't get a chance at the end of the last video, I didn't get a chance to document some of the things. This is from Chris Jackson, and Chris was calling me every day for a while he was working on his Spitfire project, and he sent a video even of this. And a lot of little details, but I want to just run through these pictures quickly, give you an idea of what a good, I think he did a fabulous job. And boy, he sure captured the look with the tiger mouth. But when I looked at this the first time, I thought he went up in a Spitfire bedroom and stole my model. This is from Chris Jackson, and the video that he sent was excellent. We were watching it in his shop the other day extensively. He has quite an Air Force. I know Joe Adamusco will be impressed. I will try to see that he gets a copy of this video. Look at the ace on the tail. Looks like he's got some kind of tricky linkage here for the Rabe rudder. And I will definitely, Chris, I will definitely pass some of these on to Stunt News. I'm sure he's going to use them. This is one of the nicest renditions of the Spitfire I've ever seen. He even did the radiators on the bottom. He even did the, I don't know where the retracts would go, and that's kind of prototypical. He went with the thinner invasion stripes. Got a nice ink work. Rivet lines. Looks like he has a removable tail wheel. I'm taking a wild guess. No captions on the pictures, but I can pretty much figure this out. And this looks like a totally different model, but look, it's got the Canon details and everything on there. From Chris Jackson. Anyway, absolutely beautiful. And appreciate it a whole lot, and we have enjoyed every minute of that video, trust me. Everybody here enjoys swapping videos. And just let me invite you, if you've got a camera, access to a camera, run over and take some pictures of your Air Force, your plane, your wife in a bathtub, whatever you think could turn us on here at the shop. One of the next projects we need to make up is the pushrod for this plane. Just want to run some thoughts here. We have the traditional pushrod that you make when you make any plane. No adjustments anywhere. One of the things we've had on several past planes is adjustable ratios. This plane we don't have at this time, but because we have access to the controls, we can go in and add a bushing anytime we want. If we have a tail horn, when a plane is a take-apart plane, and this is what we have now, if we need to extend this or add a bushing, it's very easy to do because it's a take-apart plane. It gives us that option. Now, adjustable slop would be that one of the holes between the pushrod that goes from the flap to the elevator would have an 1/8 inch hole and a 3/32 rod, and it would create some slop. Without that slop, I've found it very difficult to trim a plane to fly level. If a plane doesn't fly level, usually putting more slop in will help up to a point. We've also included on some of our ships an adjustable length pushrod, and that's worked well. That's worked great for fine tuning. But again, because we have a take-apart aeroplane, in a matter of 30 seconds, and we did it last year at the Nats, we can just take the pushrod out. So what you see here is, on a traditional plane, where you have to cut the fuselage apart and drill holes, and well, we've kind of left this in the past. We don't do this anymore. We have 3 possibilities here that at some point in time we want to try different ratios, and we have that ability to do that. We just take the tail off the plane, drill another hole. We have adjustable slop, and the way we put the slop in the plane, I'm going to detail that out right now. And we have an adjustable length on the pushrod. Now this is the little gizmo that Bill Biles sells, which is an excellent little thing. If you have one of those, that's a great way to do it, but there's even another way, is make an adjustable pushrod with a solder slip joint, and once you find where the plane flies in dead neutral, just make another pushrod without the joint. And that's what we'll do here. We'll try to set it up for pretty close 0-0, but somewhere down the road, if we need to make it, we'll just make another pushrod. It only takes me 15-20 minutes to make a whole pushrod, and that eliminates one of the joints in the control system. Some thoughts that I've had, things that I've found over the years that seem to be very, very significant. Number one, if everything is lined up, if the wing, the motor, the wing, and the tail are all in absolutely perfect alignment, you probably don't need a lot of slop in a plane. Maybe you don't need any. I'm not sure. This is an aerodynamic thing that has many sides, and I can only give you my opinion. My opinion is that all planes should have some slop. So what I have is on my flap horn, the hole that's going to go to the elevators, this hole is an 1/8 inch, and it has a 3/32 rod, and that just allows a little bit of slop. But now you have to line everything up in neutral. Well, when my flaps are in neutral, I want to be sure the elevators are in neutral. Well, how do I do that if I have a slop? Well, what I do is I take the pushrod end and put a little piece of fuel tank tubing over the end, and that lines up in my horn. Then I line everything up, and then I take that little piece of tubing off the pushrod and solder it. And this gives me just a little bit of slop, and I found that amount is a real good starting place. Now, some of the reasons that you might need this. Look at most planes, and you go to the center of the wing. You notice that the drag, parasitic drag, is not equal top and bottom. So let's pretend that you've built this plane and you decided, well, gee whiz, for flying at my flying field, I need bigger wheels. Well, now you've made it even worse, because what happens? All of the parasitic drag is below that center line, and what it's trying to do, it's trying to constantly change the trim of the plane. If you were to add something to the top of the plane, let's say you've redesigned a canopy for a larger canopy, now you've added more parasitic drag up here, and what happens is now the plane will not turn equally. A good example of that is most planes, when you put wheel pants on them and then take wheel pants off, you have to readjust the handle a little bit. I found it's a very significant thing to get this drag lined up so that the plane tends to fly neutral. Now, if it doesn't fly neutral, if this picture that this is running into, it's wanting to nose this plane down all the time it's flying. The bigger pretend right here you had a little parachute. Well, that's what that little, you're trying to equalize the pressure on, and that's what a really good design, a design that evolves over many ships, and basically the Cardinal, Strega. You can figure out where and when this could be. Now it changes in a lot of ways. If you, for instance, make the landing gear longer, that parachute just got twice as big. If you've decided, well, hey, my custom plane, I'm going to have this, you know, the Willie the Whale canopy on it or something, you've just changed. And now you have to basically go back to where you've got to get it to self-center again. Now, if this was all done ahead of time, and you were building an exact plane that had already been built many times, and you knew exactly which wheels went on it, which, well, it'd all be fine. But we never do that. We're always building something new, and that's the fun of the hobby. So we want to be able to adjust this. And one of the things that allows us to adjust is if we put a little bit of slop in the horn, it allows us to have the elevators in neutral and the flaps drop down just a little bit in level flight and in inverted flight equally. When it's done equally, our flaps will have a little bit of travel up and down, and the elevators will be in neutral. So it allows us to compensate for the fact that this might not be exactly right on a brand new prototypical plane. Use a Nobler as an example. What slop also does is as you make the slop bigger, if you go bigger than 1/8, and I wouldn't think you'd have to, maybe something really needs to be cut and changed if you have to go more than 1/8. But if you do, one of the things that, I mean, it's pretty obvious to me what has to happen here is, if this ratio, now let's just make a number up, is 20 degrees. You've got 20 degrees of travel to do a corner. When you put slop in this, you're going to allow this to go maybe 25 degrees. You're increasing flap travel every time you increase slop. The exact opposite is true. Now you can compensate for that, and you know, all these people on the market, they have horns shaped like bananas and things like, with every shape and size, and yeah, that stuff is all rocket science, it all works, but it doesn't take into account the slop factor. The slop factor, to me, is a significant thing, and having the horns at cocked angles isn't a very insignificant thing. It's like if you're going to run a race and you wax your shoelaces, yes, you'll run faster, but if you tie your shoes, you'll go even faster. This is tying your shoes. This is stuff that really does matter. Now, what happens is as a plane gets heavier and heavier, let's say, as an example, you have a 50-ounce Nobler. Well, you want a lot of flap travel. And trust me, the heavier the plane is, the more you want flap travel. A real light plane, probably like a Billy Werwich plane. In fact, I even think he wrote in his article to minimize the flap travel. And that's true. But most of us don't build super light. You build at realistic or heavy weights, and that's where it comes in handy to have slop. Because the slop, if you start with a 1-to-1 ratio, it's going to allow the travel of the flaps to be a few degrees more, and that usually generates more lift in the corner, especially if you're going to tape the hinge line shut. And the end result is you have a very easy way to test this. You can put that little piece of fuel tubing back on this so that it is now symmetrical and there's no slop. Fly the plane, go in, take the little bottom hatch on our Typhoon off, put that back in, take it out, and see for yourself. And that's always the best test of all. The best test of everything that I've ever done. And I always tell people, it's nice to call up this person, that person, call up Wendy, call up whoever, dig up Abraham Lincoln, whatever you have to. But the bottom line is the best test of all is try it yourself. See how you like it. Also, when a plane doesn't turn equally, when it turns, let's make a whole new storyboard. I was going to try to do it with this one, but this is such a significant thing. Paul Walker wrote about this in his Impact article. If your plane tends to make nice tight little squares, but on outsides it's really mushy like this, well, you want to adjust the pushrod length. And a lot of times, you can do this a very easy way. You can just make another end for the pushrod. You can cut the pushrod end off where that little piece is. You can also buy that little Bill Biles adjustable thing, which is a handy on-the-field adjuster. That's a good way to do it. But my first choice on doing this is just to have the whole new pushrod made. And an even better choice, and it's probably the choice I'll wind up with, is to have a pushrod half of the wire thickness longer, half of the wire thickness longer, half the wire thickness thinner. And then by adjusting the push rod length, as you make the push rod shorter and shorter and shorter, you're going to, or longer and longer and longer, you're going to adjust the ratio. If you shorten the push rod, this turn is going to get tighter at the expense of this one getting bigger. Now, Paul Walker wrote about this on his little trim thing, and it's an excellent thing to refer to. But this is all part of having all these adjustments. If the plane is a one-piece plane, some of these you have to make hatches for and other things. But if you have a, here's the bottom line. A take-apart plane, it's like having your cake, like having your push rod and eating it too. You have all of these possibilities because you can get in at it, make a new push rod longer and shorter, adjust it, adjust the slop. You can do all these things, and that's why I say over and over and over again, it's a pain in the neck to make a take-apart plane. It takes a lot of extra labor, but somewhere down the road, it pays dividends. Well, you know what? Right now, as we go, and we'll probably make the push rod today, the dividends start to pay back. And that, to me, is what's worth it. One of the other things that's worth it about a take-apart plane. One of the things I've kept in the shop for a long time. This is a spare push rod. You can see how we put a little detent in here on the end that we're going to solder. Leave enough wire sticking up here. And we'll do one of these real quickly on video. But having this joint here, this allows me, first off, to put the plane together and get some idea of what the overall length should be. Now, the end that's going into the front hole, I need to put a little piece of fuel tank tubing on here so it'll center it back to 0. Now all I need to do is, this is going to give me my slop. It's this little piece here that's going to give me the slop. It's just with a parting wheel, cut off a piece, 1/8 of an inch or so. And this is only going to be, the only reason I'm going to use this little piece is to line up the flaps and elevators. Once I think they're lined up, I take this out and this self-centers my push rod so that the slop is the same amount up and down. It's just a piece, a spare piece of common fuel tank tubing. The first thing we need to do is figure out where neutral is. I haven't made up the permanent wires yet for this, but what I want to do is get the flaps in relative neutral here. And then I need to pin them in place. Now what I can do if I'm really in doubt is run a parallel line, and I've already done that with the rivets, so I can see, get this exactly zeroed up into neutral. I have both sides pinned, and I have the push rod just attached with that little piece of copper tubing in it, and what that's going to allow me to do is just get a rough idea now, and I mean the roughest of ideas. When I put the stab in place, if I need to make this a little longer, a little shorter to start with. But I'll always have that little ability to fine tune it by heating that soldering joint. When I get it right, then I'll just make a push rod. And then that'll be my neutral gauge, so to speak. Okay, now that's hooked in. Now, the push rod's installed up in the front. We need to just bolt the tail in place temporarily. I use the same little aluminum washers from Micro Fasteners. The address is on the previous video. And now I need to look in and I can see how much longer or shorter. Just make sure this is in, it hasn't changed. Now by looking right in there, and let's see if we can do this on camera. Hey, let's quit fooling around. We can look right in there and see how much we're off by. I would guess, it's not like we're off. This is our go, no-go gauge. But this is our, I'm going to guess, a 1/2 inch. So I need to make my test push rod a 1/2 inch longer. And then I can make my 2 gauges to line up the elevators. I have that. I can reference off the rivet lines. And when I take out my little piece of brass, everything should line up perfectly. Famous last words. If you've ever done one, you know that never happens. You know, I can just take an eyeball guess of how long that piece has to be. I don't even have to solder it. I could CA it. Because I'm just making, see what I'm doing? I'm making myself a pushrod length gauge. Put out this way, roughly. Actually, if you didn't want to make a test pushrod, you could just use a piece of 3/32 wire. Okay. First step is to make 2 pushrod ends with a precision drill. Since we use an 093 wire, I want to use an 093 drill. I want a tight fit, but not a fit that's so tight that I cracked it apart when I put it in. And a couple of things, when you're bending a pushrod wire, you don't want to get a perfectly kinked bend. You don't want to have this be such a 90 degrees. You don't want to put it in a vise is what I'm saying. You want to have a little bit of a radius out there. Now the same thing, I'm going to make up the 2 little pieces of wire, the extended ends. These are the ends. I always bend them this way and then trim them off rather than trying to bend it so small, because we only want just a little bit to stick up out of the pushrod. This is the primary end. This is the end that's going to wind up going in the front of the plane. And what I want to have happen here is I want to have these are the little, there's going to be double wheel collars holding this on, so I want to have this little knurled part so that the little set screws can drop in there, and I'll have redundant system double. And I want to have the hole in the pushrod here so that this will slide through, and then I'll trim it off. Key part here is to leave enough sticking up. This is on the end it's going to go in by the flap horn, and I want to wrap this with CA and carbon fiber. And that's just a little reinforcement because I have seen these break after a plane's in service for quite a while. You see they split the long way. You get plenty of thin CA down in there so this gets nice and solid. Now we're not going to do this exact thing on the other end because we're going to want to use this as our fine adjustment. But this end will be permanent now. We can make this a permanent end. What makes this possible to get a fine tuning on this, you can see what I've done is elongate the hole where the wire is going to slip through on this side. This is the side that's going to go on the elevators. Once that's through, and you want to make sure some of that is sticking up, of course, now I can push this in. Now this hole's just tight enough that I can move this. You can see what's actually happened. I have a fine adjustment, and once I get this in place, I'll set the elevators, which will set this right about where I think neutral is. Then I'll lock it with 1 drop of CA. Make sure everything's in neutral the way I want it, and when it's done, I'll fill this end with thin CA and wrap this with carbon fiber. But this will give me that final fine-tuning adjustment that I can find dead neutral on. And then I just need to wrap both ends with the carbon fiber. Copper fiber, that's a new word. Yeah, this is just a test fit. I know I have the flaps locked in neutral, and I have the elevators because I know this is a flat tail and it's at 0, and I know exactly how much it should be between the elevator and a straight line, a parallel line. So it's this little dimension, and I have no slop in the system now. This is at neutral, this is at neutral. Now I can take the push rod out and lock it in permanently. I've had that little adjustment. I've got this fine-tuned, and it is as close for a starting point as I think I'm going to be able to get. I can lock it in and then carbon fiber up the push rod. Now that I've established the length, I can take this little piece of tubing off. I probably have to pull it off with pliers. I had it forced on. And that'll set me the clearance that I want. In the other end, I'm ready to wrap with, I put CA in there. I'm ready to wrap this end with carbon fiber and dress it off. And that'll be our test push rod. Now it's best just to tack, and I shove that piece down into the little cavity there. And then wrap the toe. And if you don't have any of this toe, I can supply it to you because usually you have to buy a big giant roll for a couple $100. You can't buy small amounts, and I'll be glad to share it with you. But this just keeps the end, and if you didn't have toe, one of the possibilities would be just wrap it with copper wire or string. That would be a little bit heavier. Some fiberglass thread. Now once you get to the end, here's where it gets tricky. You want to hold that and point it down, otherwise the CA runs. And I just let that sit and kick without kicker. And then of course I'll dress it all off, sand it down. And one of the things you can do is dress this off, just hit it with another coat of thin CA. Don't breathe the dust in, of course. Anytime you're sanding carbon, you want to wear a mask. And this push rod is ready to install. We'll put double wheel collars in by the flap horn, solder the back, and that'll make sure everything's still at 0, 0. Next thing I'm going to do is solder a little washer on here with a little copper wire safety, so that even if the solder joint fails, in theory the copper wire would be a redundant system. I see the wire. That's my redundant system. Stay bright silver solder, deflux it. Now the tin foil is always a good idea because some of the flux can splatter. And I would always notch the wire and just put in a couple wraps of the thin copper wire and deflux it with baking soda and water. Well, it looks like we've been relatively lucky. I put the real wires in here, took those ones that were oversized out. Looks like we've got some really nice control movement. And the next thing I want to do is I want to tape the hinge. I just put them in this position. I lay the tape out on a table and strip out a piece. This looks like about 7/8, 3/4 of an inch wide. So I strip this off with a razor. Of course, it's way oversized. I want the controls totally deflected in the opposite direction. And when I take this off, of course every time I remove the control surface I have to take this off, but a little bit of heat with the heat gun a la John Brodak. We have the little hook in the wire here so that it can't walk its way out. Now usually there's some noise or whatever you want to call it in the very beginning until that works its way in. And see, it goes away eventually. But with this system you really have to tape the hinge lines. Now we got the hinge lines taped, the controls finalized, and this is possibly the smoothest set of controls I've ever made. That is trying to piece this together here. I have a little bit of time left. I'm going to get the tail section on with an aluminum bolt and set up the Rabe rudder linkage next. I'm trying to dope this out in bite-sized pieces that I can handle. Hey, this is the first time it's been buffed and actually, oh, get out of here, all in one piece like this. So you really get a nice overview. You can see the finish really is nice. Anyway, instead of belaboring a point, what I want to do, I want to get busy. Maybe I can get even more done. I want to get that tail section in the Rabe rudder linkage set, and I'll feel like I really have accomplished something today then. And the controls are just as free as if it had, you know, a whole season of flying on it. As we were with these hinges, getting the epoxy out, this still seems like they could be a little bit freer. So what I'm going to do is put a little bit of 3-in-1 oil on here. And if that doesn't free them up, a little bit of penetrating oil. See, because now the pockets are relatively sealed. And as careful as you are, you just never can be too careful. That epoxy has a way of working its way in. But I think we have a nice, oh, that's better. We have a nice set of sealed surfaces now. Now the screw that I'm going to use, the screw that'll be the actual screw we're going to fly it with, will be an aluminum 440, and we'll use one of those aluminum washers. Now here's a magic trick. We're going to make the tail appear. Abracadabra. For a magic trick. This is just about the, well, as nice as I've ever seen it go together, because we haven't seen it all together in one piece yet. I guess after all the hundreds of hours of work, I deserve a little walk around here to look at this guy in one piece buffed out. Well, except for the nose. We're going to do the nose last. Okay, now next thing I want to do, I want to set this linkage up. And I want to set it up so when I'm in neutral, I have just a degree or two of offset. And on full down, I have maybe 10 degrees, something like that. And that's basically a ballpark starting point. From there, you'd want to, of course, try a little more, a little less, and see what kind of results you get in terms of performance at the top of the hourglass and a square 8. But the Rabe rudder Rabe rudder, I should say, always seems to be a valuable tool. And now that we have it on Miss Ashley too, we should be able to use it to our advantage at points, and especially with using bigger and bigger props. And we don't know if this is going to wind up with a 4-blade or a 6-blade or a 16-6 or what. We have a whole lot of uncharted territory ahead of us. I've been trying to work out, I want to be able to get the ball link on and off, and we've allowed for that. But I can't get I don't have a tap, so I can't thread both ends, so I'm going to have to put a slip joint in here somewhere and cut 2 pieces with thread so I have threads on both ends. And that looks like it's going to be easy enough to do. And it'll also be removable. You'll be able to I want to have this accessible at the field. I don't want it to be a pain to get at it. I made it oversized so I can shorten it. I'm going to shorten it. Now I just need to do a solder joint on this. This is probably the easiest way to do this. I'll link it the right length. What I'm trying to do is, of course, deflux the joint, polish this up just a little bit, try to give it a finished look. We are closing in on, actually, I didn't think I'd get this much done today. Even a little detail like this, I think, is, you know, it just makes the plane look finished. It makes it look like we care about even the smallest detail. Again, I'm looking for, these are the things that I'm careful of, that I don't have this rod running into this in the end, because we have that half a fillet in there. I don't want any, actually if I use this hole I'll have to bend the rod, a little kink in it. I don't want to do that though right now. But that's about how I've set it up to begin with. And of course that's always adjustable as need be in flight. I want to do some dry fitting up on this engine combination. First off, I need to put on, before I do anything, I want to switch to the prop, the thrust washer, if it fits, that has the pins in it. The one that Bob Zambelli made up. This may have to use the puller to get it off. But I'll spend the rest of the day doing up some dry fitting here. I want to look at how I'm going to have to take the muffler and tank all of these components apart when I go to do maintenance on this. And I want to see what the spinner, well, the first thing is I want to put that, I ought to do it in order. This is the motor. This is one of the few modifications we're making to it. One modification is to loosen the two carburetor screws and move this over so it sits almost in the center of the model now. Just make the linkage to the carburetor a little bit easier. The motor's already broken in. And I need to remove this with a puller. And I have one that Bob Zambelli made up that he turned the diameter down to fit inside our spinner backplate. And also at the same time with a precision jig made 2 pins so that we can possibly upgrade the ability of the motor to, if it backfires, to loosen the prop. Like everything Bob does, it's really world class. Nice little accessory item. The jig block, the adapters, and some aluminum washers with knurls, real knurls. You know, once you have this, you need to be able to drill a spinner backplate and everything a precision fit. You just can't put 1/8 inch holes on this. It'll be sloppy. You want a nice tight fit once that's put on a motor. I'll show you what a precision fit this is when you get this on. Wow, that really socked up nice. And now I just need to do the prop. That much should at least help lock it in place. All the props we use, once we have the backplate, and we're going to buy a couple of spares, we'll have the tool that Bob came up with worked real well. We half relieved the prop. And we need to key it in exactly so that it doesn't hit on the detents. It's such a tight fit. In fact, I may have to go 1 drill size over because it's a tight fit on the pins. 1 drill size oversize, and that keys right in there. Now we have a whole keyed unit. As long as I'm setting up Bob's little jig to do these props, I may as well get a couple of spares made. These are the 14.5 rev ups, and these are ones, and we'll balance them, of course. But these are the ones that once they have this little modification in the back, they'll be ready to use on the Typhoon. And if we break all 5 of them on the first day, shame on me. And once we decide to start experimenting with props, each one is going to now need that little detent. I think that's a good safety feature. Found when doing all this bench running on 80s and 70s and 90s and 65s and all of these engines that we've been playing with, one of the things we found is that the Satos especially are not real critical to exhaust tuning. They're probably made for mid-range, cam timed or whatever. They seem, excuse me, very uncritical to the exhaust system, which is a real plus in this case, because what I did, I wanted to just snap the whole Typhoon together, basically because I just want to look at it like a voyeur tonight. I haven't really ever seen it all in one piece yet. And so I wanted to put the muffler on and put all the hardware on a spinner and balanced up a couple of 14.5 rev ups. And I thought, well, this weekend I may shoot some pictures of it, so I'd like to. Of course, it's going to have retracts right now because it has no landing gear. And if we hand launch it and land on the scoop, that'll be fine. And anyway, one of the constant maintenance things is just keeping a muffler clean. Just for my own personal, I just like the way it looks better. And the aluminum that Sato uses, it buffs up on a buffing wheel real nice too. First I get all the oil off. This is one that's already been run. Thought I just, in case we do get time to take some pictures. Again, I like everything polished and neat and clean. I want to show you how quickly you can buff up a Sato muffler though, because the reason is it's really good aluminum. Look how quick that buffs up. It's only going to take about 5 minutes to do the whole thing. And Now, one of the choices we have is to try some different exhaust systems. We have a 90, 91, 72. See, one of the unique things is I have to be able to keep the oil away from the area where the Zetron is. So that's one of the things I got to be careful of. I got to kind of take it into account. And it's nice that these engines are not real critical. Otherwise, we'd really be in a little bit of a bind. Just look how nice this polishes up. Boy, that adds a nice touch. Now, as planned, within our major plan, hey, we could use the wider muffler. We really have just enough clearance, though, really not a lot, so I would have to get a header with a little less bend. This is a 90 that I have on here. That's the one Warren Walker made up. But this is the first time we've had it all together, so we're being a little bit of a, you know, just critique. Starting to really get exciting now the last couple of days. We got to make the gear up. We have to fit the Zetron. I made a little list of all the little things left to do. Got to get myself a pair of wheels. Figure out how and where we're going to mount that battery pack. No matter what angle you look at it on. This is the first time I've actually, in the last 5 minutes, the first time I've ever seen this all buffed out in one piece like this. The most impressive part to me is the way the nose section came out. And the finish is, the Brodak dope finish is absolutely beautiful. Now, it remains to be seen whether people are going to have any appreciation of the airbrush work. We're certainly going to find out. Anyway, I got my list together and we're going to look at making up the final little parts for this project. And boy, from this point on, it really does. This is one of the impressive things, is how nice the controls came out. They're just sweet. This section I like with the manifolds, the filters. We don't know which muffling system we're going to use yet. But I had the vision when I started this of getting a whole 4-stroke, the whole 91 inside the cowl. And trust me, it's in there. There isn't even a hole for anything. And after so many 100 hours of work, it's really, really nice to be able to see this guy all in one piece. And the last thing is the gear, and we are going to try to make a pair of really scale gear so that when it's sitting, it'll be sitting up high on the gear. We can taxi it around, land it on the gear, and hold the tail wheel up. Anyway, been a long day. We'll be back to this. I can't wait for tomorrow. It's this kind of a day. It's the kind of day I wish would never end when you get to this point. Hey, been a lot of hours to get up to here. And I guess it's in the eye of the beholder how much it looks like a Typhoon, but to me it really has the look of the look that I was originally striving for. Anyway, see you tomorrow. I'm beat. Today I want to get the landing gear roughed out anyway. And what I always do is I save all my old landing gear legs from, these are some spares we had for the Spitfire, for a couple of reasons. See, these are Spitfire gear, and they're different lengths, so I can get an idea now, because I know I want to have clearance for a 15-inch prop. So I can just use these just to plug them in, since all my landing gear plug in the same. And it's a good idea to have a spare, or even to bend a few. We could even use these spare wires we have here, and some different size wheels. Now we're hoping to use 2.5-inch wheels, 2 1/4. I don't know. We're gonna be looking at all the possibilities here. But the first thing I want to do is put on the shortest set of gear. These are the shortest, and I think these are the longest. These are the longest. So I can just plug them in, so I can get an idea of how much prop clearance I have at this time before I bend up my wires. And this would apply to a wooden airplane, it doesn't matter, any airplane. Gauge, and I have a piece of tape on here so that I can measure how deep into the wing the wires go. Okay, and I can pretty much get a gauge on 1/16 of an inch less, so I'll adjust the gauge. Now the way I bend up the wires on all the planes, pretty straightforward. It would work on any plane, work on a Cardinal, an SV-11, any plane that you want to have wing mounted gear to track real nice. Remember, we have 2 landing gear blocks in here, so I want to make sure I'm getting into the, I got to do a little, there we go, where it's sitting in that block. And what makes this system work so well is that we have 2 blocks, and we have plenty of leverage on the wire. Now I can get a rough idea about what my prop clearance would be. This will give me a relatively accurate, because it helps if you don't have a bunch of paint down in the little recess. You've got something down in there. Now the prop clearance changes. Well, we got something down in there. Maybe some Bondo or something, I don't know. I'll have to clean it out. Anyway, we have a lot of choices here. Just by changing a wheel we could get more prop clearance, or by bending the gear back. But we have a real accurate way, since the plane is all in one piece now, a relatively accurate way of getting the gear angle figured out before we actually go and make the gear legs up, even though we can change it later. It's nice to have it real close on the first flight. With this gear length, they're definitely not going to have enough prop clearance. So I'm going to go to the biggest ones, and if anything, I'm just going to wind up this, because we don't really know if we're going to wind up with an even bigger prop. I'm just going to make them to the longest length of the landing gear. All these gives us a real good idea of where to start with our gear leg length. Of course, you could do this on the plans, but then you never really know. You can't take into account the amount the gear flexes, or where the CG is, where that angle on the gear is going to wind up. So this is for me a more practical way to do it. The well-used wire bending jig. We have 3 of these. We got these from John Brodak, and they work to perfection because they put just enough bend in a wire that you never kink or fracture the wire because of the radius on the pin. Again, available from John Brodak. This is the heavy-duty one because we bend horns with this. Jimmy uses it when he runs production runs of 1,000 horns. This works perfect. Wired, a couple of things. You don't want to bend it any further than, I said wire, not birds. You don't want to bend it any further than you have to and then bend it back. You'd like to bend it right up to the point, especially on control horns, things like that. But anyway, the leg that's going down into the wing, we don't care about the length. We'll trim that off to our gauge. But I always put a piece of tape on here because this acts as my go no-go gauge, and wire always springs back. So if you were to just measure 90 degrees and bend it, it's going to spring back. You got to, according to each piece of wire, you got to kind of It's hard to explain until you've been disappointed a few times. Now I'm going to estimate what I think is going to be my spring back here. And what I do, you can make all kind of dead stops. And this can move. That gives me a little bit of a... Now, I take this out. It looks like it's not 90 degrees. Let me get a triangle. And which is probably going to tell me I got to move that tape just a little bit. Yeah, see, I'm less than 90 now. So what that's going to mean is when I come around, okay. I want that tape to move just a bit. Let me get it off. Let's see, now this won't really be super accurate. I've got to do this every time I work on something, and I'll move it to there. Let's see. And if that works. I think it's safe to say one of the jobs most people really don't enjoy. Now see, I'm still not quite 90, so what it means, I can move the tape even more. But eventually I'm going to hit this, and then I'll bend a fresh piece of wire. This is just a sacrificial piece of wire. And see if I have. Once I establish a 90-degree bend, the rest is relatively easy. Now let's just see if we can get it. Now that's too much. I can see that already. So we need to go back. Now when we're doing production things, we make a little dead stop and hot stuff it right in place. But first we have to set up where this particular batch of wire is going to bend at 90 degrees. Now the one thing I'd never want to do on a part we're going to use is bend it back. But this piece now is toast. You start with the other end of the wire. Once you get a 90-degree bend, you are pretty much on the way to success, and the rest of the landing gear bends are kind of easy to predict. Eventually, if you go back and forth, and that looks pretty good. What I have is a piece that I know fits into the wing, and I'm looking down at, because I have to allow for the wire being pulled into the jig, and I'll make this will just be a test. So let me just, and then I can adjust it longer. You know, you're always going to have to bend a few pieces of wire. With that test, I'll try to line this up and make another 90-degree bend. Now I can adjust that line. Just allow that the wire shrinks. Now it looks like I'm on the long side by 1/16 of an inch. So what I can do is adjust my angle right here. This is now. Now it's always good when you bend in wire. Once you get done bending it, bend a couple extra sets. The reason is we want to ultimately, we probably won't do it right now, but ultimately make a set of grass gear or whatever. Now I can see by how much longer this is than this one, and adjust my dead stop. I have a pretty good idea of getting those first two bends. We just leave that oversized and trim it to match. We know that's going to be real close to 90. And I know when I put this back in here at my second mark, and once I get this right, I'll bend up a couple of sets of wire. And I've got the first two bends now, and I can do this over and over and make a bunch of these. Effective prop clearance, and one of them of course is the wheels. We save all our old wheels for just such a day so we can decide which set we're going to ultimately wind up using. I got the two wires bent. Now it's the angle forward that's going to determine the ultimate prop height, and I want that angle forward. I have a very specific thing in mind when I do that. I want to have it that when I put the nose of the plane down and I let go of the tail, it rests back. If it stays in that position, the gear are too far back. If it just drops like an anchor, well, you can figure it out. We're looking for a point where we just let go of the tail and it just drops down very casually. Now we'll start by eyeballing down here and seeing that I can see this wire is further forward, so I need to take that one, bend it further forward again. And then we'll flip it up on a table and check for the clearance. And the wires, and see that they're both relatively parallel. In fact, the back one's got to get bent just a little bit more forward. And then I'm ready to do my test. And boy, this works on any plane. Gets it almost perfect on the first shot before you ever even fly the plane. I found this to be the absolute key to getting it set up right. And this is for tar. For grass, I like the gear a little bit, maybe a lot further forward, depending how rough the grass is. This is a 14-inch prop. That looks like we would have enough, except we're not in a level takeoff mode, since we're going to want to run a takeoff. And that only gives us a 1/2 inch. Well, not crazy about that. What I ought to do, because this is a critical adjustment, and and that's probably a little bit down. Okay, I'll make the next set of wires. I'll keep these as a spare set, make the next set 1/4 of an inch more. But this is the test. And this is the critical, this is the tricky part. The plane is on its nose. You let it go and the tail comes down slow. Now see, that's too far back. If that didn't come down, means we're close. See how close we are? We need to go just a bit further forward. But the other thing it's telling us is we want to make the wires 1/4 of an inch longer, because that'll allow us to bring them further forward. So now we know the two critical things. Make the same set of wires up 1/4 of an inch longer and maybe 1/4 of an inch further forward. And then we'll keep this as a spare set. We have all these dimensions written down, and we have our test gauges. Making up the next set of wires, and we can do a fine tuning on them relatively easy. And I want to show how I adjust the leg length. To replicate a set of wires, I have all my dimensions, and this is why I always bend an extra set, because while you have this all, see, I've written it all down over here, while I have this all fresh in my mind, it's easy to make another set. It only takes a few minutes more. But if I have to reset this all up later on, because I want to make grass gear or a longer set, a shorter set, it's a nightmare. And just having this ability to do this accurately, relatively quickly, we know that goes to that mark, and we can make a set of wires up. Now whenever I mold the landing gear covers, like on a Spitfire, I always like to use somebody else's wire so they can make all these fine adjustments before we do the molding on it. Okay, now I know I have this. I want to go to 4.5, and notice that I'm using, let me do it so you can see it without that piece in here. This is my leg length now that I'm adjusting, and this is a real good way to do it. I butt this up here, and I find the center of the wire at 4.5. I've got it written down because I'll forget. At my age, you forget everything. Now this was 4.5. Now I want to make it, let's add 1/4, let's add 3/10. Let's make it 4.8. And that should give us enough clearance, and that we can move it a little bit further forward. 4.8. And this will work every time. And I know that 4.8 is the amount I want. I can get rid of all these other numbers. And I've got all the marks, all my gauge marks. I can make sets of wires up in a matter of seconds. Here I have the original piece I made, which I used to get my top angle. Not the angle, my top length. I can line this up this way. I get it right pretty much every time. Famous last words. Amazing when a camera's running how you can't get anything right. Okay, this is running. And so I think one of the worst jobs of building a plane I think these tips will help you, I hope so, and give you an ability to make an extra set. For instance, if you know you're going to make the same plane next year, you may as well make up 2 or 3 extra sets right now while you have all those marks on the jig. Sure, even if I decide to go to a little bit bigger wheel, that I have enough length here, so I'm just going to add 1/4 of an inch to the length when I cut that off. Give myself every possible choice right up to the time we fly the plane. Now I know the angle on this is a little bit too far back, so the wire that I'm actually going to use, which is a little bit longer, and what I did, I made 2 sets. I made one even longer so that I can make up a set of grass gear where it tilts even further forward. But see the angles I'm trying to line up? I'm trying to get these to line up and my new wire to be maybe 1/4 of an inch further forward. I can see the angle is just a little bit further forward, which is what I wanted. Now I can take the original test piece out and match the matching leg to this so that I have the 2 new matching legs. I've got the angle just right. I'm, for all intents and purposes, done with my test wires. These are just going to be spares. I'll take the wheels off and put them away because I have a set that matches and I have a set of spares. I have these 2 exactly where I want them. Now what I want to do is I want to take the spare set of wires, which will be my tar gear, and get them even, that they're just about maybe 1/4 of an inch further back. And again, I'll take one out at a time, replace it, and match the other one. Angle set on both sides. Now the key is, and this is really one of these hit or miss things, I want to lay a straight edge right across both wires and check that they're not towed in and towed out. I want them to be in alignment with the lead out so I can kind of hold I'm in the midpoint on the lead outs, run my 48-inch straight edge right down the wires and tweak them. Really not much more annoying than when you have a ship that you go to take off and it either wants to steer in at you or steer away or do one of these dog shaking the tail things. And what I found, 2 things really important. Slop in the wheels, a little bit of slop so they can self-center, because it's every time you move the lead outs you'd have to move the gear to a certain amount. And I've had planes that when you move the lead outs back,